This is number 3. Number 3 is a fairly quick question, but it hits at one of the core points of the entire chapter. It says, state the null and alternative hypotheses for the anemia study. So I just have the original problem up from number 1 here, that anemia study. The null hypothesis is usually what is presented to you, what mu is, and the alternative is that mu is either not equal to that, less than that, or greater than that. So let's take a look here. Hemoglobin is blah, 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 just background. People with less than 12 grams per deciliter are anemic. Okay, well, so we'll remember that. A public health official in Jordan suspects that the mean for all children is less than 12. Okay, so someone suspects that the mean is less than 12. So we'll keep that in mind. He measures a sample of, let's say, 50 children. Suppose the simple conditions hold, etc., etc., etc. That's all it says about the mean. So when you read that, what you're looking for is the mean that's presented, mu equals 12. That's what they're saying here. The assumption that mu could equal 12, and someone else suspects that it's less than 12. So that means that the null hypothesis is that mu is equal to 12, and the null hypothesis is that mu is less than 12. And the less than 12 here, you can find right in the text. The null hypothesis isn't as easy to find. However, you have to assume that whenever a mean is thrown out there, that's going to be the null hypothesis. Whatever you are trying to break, whatever you're trying to prove against, is going to be the null hypothesis. So the person who did this study thinks that it's going to be less. However, in order to prove that it's less, they have to make a null hypothesis that it is actually 12, and then try to reject that with their data by saying that, no, it is in fact much less than 12. So that's how you do number 3.